Hi everybody, this is your grade 10 science review. So if you want to download the science review, check out the link down below. Attempt it, try some questions, make some mistakes, circle some questions that you don't know, and watch this video and follow along. Hopefully the explanations will help you. So to start off with this one, let's look at the first unit, which is about chemistry in action. This is about your chemistry unit, your periodic table, your atoms, and all of that stuff. So question number 1 is looking at where exactly are those groups located on the periodic table. So to study this, you should familiarize yourself with the periodic table because it tells you a lot of things. It shows you all the elements in your universe. So it's actually a pretty unique table to have. So let's look at the first question. Where are the following groups on the periodic table? Letter A, it's asking for halogens. So in your periodic table, you have number 1, number 2. These are the main ones that we talked about in class. And then we jump over to 16, 17, and 18. So these ones are the ones with really unique names to them. And for group number 7 or 17, these are your halogens. So anything from here, all these ones down here, these ones are your halogens. So you can include this one as well as like the new element. But those ones are your halogens. That means that these ones all have 7 valence electrons on its outside shell. 7 valence electrons, that means that they can take 1 electron in to form a bond. The next one is your alkali metals. So alkali metals are all the way on the left side. It's the first group, and because of that number 1, the first group, they all have 1 valence electron on its outside shell. That means that there is 1 electron that they can get rid of to form their bond. So anything from hydrogen, lithium, sodium, potassium, rubidium, cesium to francium, all of them would have 1 electron to get rid of on its outside shell. That's your valence electron. The next one, just right beside your alkali metals, actually can contain the group alkaline earth metal. So they are in group number 2, and these are ones are your alkaline earth metals. That means that they have 1 extra electron than the first one, so they have 2 valence electrons on its outside shell. That means that if they were to form a bond, they would have to lose 2 valence electrons to form those bonds. And the last one, these ones are the most stable of them all because they're called the noble gases. They're all on the right side in this group number 8 or 18. That means all these gases will not be very reactive because they all have that 8 electrons on its outside shell. So these ones are not very reactive. They will not lose electrons or gain electrons unless it's different circumstances, but very unlikely. So these ones are your noble gases. For number 2, this is looking at the basics of the atom of protons, electrons, neutrons located in an atom. So here I have a really useful smartboard, a flash where it shows you and building an atom. And when you look at this, your protons are found in this nucleus in the center, and they all have the positive charge. And anytime we have an atom, you always have your protons, electrons, and neutrons if they're in a neutral state. That means that they have the same number of positive and negative. So if I have 1 proton right here, I would need a electron to balance out the charges. If I have 2 protons, I would have to have 2 electrons to balance out the charges. If I don't have the same number of protons, electrons, that will actually give us a negative or positive charge. That means that if this atom were to gain an electron in its outside shell, you can see now I have 3 negative charges on the outside. So that means that I have 3 negative charges compared to 2 positive charges, which gives you an overall of -1 charge. And to look at the neutrons, neutrons don't play a role in the charges, but actually plays a role in the atomic mass. So that's like the decimal number that you find on your periodic table. That's how heavy your atom is. The bigger your atom, the more protons and neutrons you have, the heavier it is. So in the neutrons, to determine the neutrons, you actually need the atomic mass to figure that out, which will lead us into the next question. So in question 3, we're looking at the atomic number, protons, electrons, neutrons, and the Lewis-Dot diagram. So let's start off with looking at for nitrogen. Let's look for nitrogen. That's your number 7. That's your atomic number 7. So the whole number, non-decimal number, that's your atomic number. Well, what can the atomic number tell you? That's the number of protons that you have. So if you have atomic 7, that's 7 protons. And if an element is sort of neutral, you assume if it's neutral, because if it's not neutral, you always have a charge. So if it's neutral, you would have the same number of protons and electrons. So the protons, electrons would be the same number. So then this leads us to neutrons. How do we calculate the number of neutrons? Well, neutrons don't play a role in the charges, like I said earlier, but it plays a role in the mass. So the atomic mass of nitrogen is 14.0087. So if we were to round this, this is going to be 14. And what this 14 means, that this 14 is the number of protons that you have in your atom plus the number of neutrons. So then how do we figure this out? Well, this is just like a math equation. So if you have 14 on this side is equal to number of protons. Well, how many protons do I have? 7. Plus neutrons, which is my unknown. Well, isolate your n. So if you subtract 7 here, subtract 7 here, then your neutrons is 7. That's how you figure number of neutrons. Don't think that neutrons is always going to be the same as protons or your electrons, because as your elements increase in mass, the number of neutrons will actually increase more than the protons or electrons. And then the Lewis dot diagram, this is looking at the valence electrons. So let me just erase that stuff right now and show you what this is all about. So the Lewis dot structures is just looking at the valence electrons, and you know that for nitrogen it is a halogen, so it has 7 electrons. So let me just kind of get my marker up. So nitrogen, I'm going to put N, that's my element, and because it has 7 valence electrons, I'm going to put 7 electrons around my element. This just shows, this is a quick method of showing how many valence electrons are around your element. So this is nitrogen. That's your Lewis dot structure. So let's look at B, potassium. Potassium is right here. This is number 19. So it should have atomic number 19. Proton is 19. 19 here. And electron will be 19. And number of neutrons depends on its mass. So the mass has 39 point something something something. So I'm just going to round it off to 39. Subtract your protons, which is your number of protons, and your number of neutrons will be 20. That's your number of neutrons. And then let's look at C. Barium will be down here. This is for number 56. So this is 56. Protons will be the same, 56, and then 56. And number of neutrons over here, we have to look at barium, which is 137. So this is getting a little bit messy, but 137 minus 56. And the answer to 137 minus 56, I'm just going to punch it in my calculator. I think this is going to be like 79, I believe. Let me see. 137 minus 56. 81. Oh, that was really bad math. 81. That's the number of neutrons. So if we were to look at the Lewis dot structures of potassium, remember potassium is in your alkali metal, so it has 1 valence electron. So the potassium will just have 1 electron on its outside. If we're looking at the Lewis dot structure of barium, barium is in your alkaline earth. That means it has 2 valence electrons. So barium would just have Ba here, A, 1 here, 2 electrons, and that's it. And then for oxygen, this is right here. So it has an oxygen atomic number of 8, and then protons would be 8, the electrons would be 8, neutrons would be 16 minus 8, which is also 8. And the Lewis dot structure, oxygen is in your chalcogens, which means it has 6 valence electrons. So your oxygen would have 6 electrons around it. So there's 1, 2, 3, 4, 5, 6, and that's it. So that's your Lewis dot structure for oxygen. And then bromine, which is your halogen, which is in group number 7, is right here. So I'm just going to skip all these protons, electrons, and neutrons and just give you your Lewis dot, because it has 7 valence electrons. You have 1, 2, 3, 4, 5, 6, and 7, and that's it for bromine. And then aluminum is here. This is in group 1, 2, 3, so it has 3 valence electrons. So aluminum would have 1, 2, 3, and that's it. And your atomic number will be 13, 13, with your protons the same number of electrons. So that's how you figure all that stuff out. So let me just erase all of this for now. So for question number 4, we're looking at the differences between ionic bond and covalent bonding. The reason why we need to know the difference is that the naming of these are actually different between the two, and also how they're bonded are different as well. So in ionic bonding, this is actually between a non-metal and a metal. So when we're looking at what a non-metal and a metal is, where they are, if you look at this ladder on the periodic table, this actually separates between your metal and non-metal. So everything on this side are going to be your non-metals. So this is what this is saying. So these are all your non-metals. And then everything on the left side, these ones are actually your metals. So these ones are all your metals. So whenever you have an element that is a metal bonded with an element that is a non-metal, that will make up your ionic bond. And then a covalent bond will be two non-metals. So for covalent, it will be your two non-metals. So if you see something that has a non-metal combined with a non-metal, that's a covalent bond. And also, how they're actually bonded is that in a covalent bonding, the electrons are shared. Whereas your ionic bonding, they are transferred. So it's getting the electron from one element to another. That's what an ionic bond is. So then if we were to look at number 5, we have to identify if these ones are ionic or covalent. So if you look at A, so in order to determine that, you look at these elements. There's a P and there's an O. Where is the P? This side. And the O is also this side. That means that you have two nonmetals. That is your covalent. And then for number 2, letter B, you have your calcium, and then now we have this OH. OH, now this is a little special ion because OH is what they call a polyatomic ion. That means that this ion comes in that package of hydroxide, the OH all together. So you don't need to separate your oxygen or your hydrogen. So anytime you have a Ca, this is on this side of the metal side, combined with a polyatomic, is always going to be an ionic bond. So that's going to be an ionic bond. And then for letter C, this is between Ca and Cl2. So if you look at Ca is right here, and then Cl2 is also here. So then you have one that is in the metal, one that's in the non-metal. This makes it into an ionic bond. So CaCl2 is an ionic bond. Letter D, this is Na2O. So sodium is over here, number 11, and oxygen is over here, number 8. So because you have one of the metal, one of the non-metal, that will give you an ionic bond. All the importance again of this is that the naming of these will actually change. Letter E, this is your common CO2, your carbon dioxide. So if you look at this, you have your carbon and oxygen. Since both of these are on your non-metal side, this is going to be your covalent bond. Letter F, this is NO2. Again, this is going to be N is here, oxygen's here, so this is going to be a covalent bond. Moving on to G, these ones are in your name, so carbon tetrachloride. So looking at this, you have carbon and fluoride, so chloride here. So both of these are on the non-metal side, so this is going to be your carbon. So let me just erase these so that you don't get confused over this. And then the letter H, we have silicon dibromide. So silicon is number 14. Bromine is 35, so because you have 2 on the non-metal side, this is your covalent. Letter I, magnesium is over here, and oxygen's here, so you have 1 of the 2, so this is going to be an ionic bond. Potassium nitrate, potassium is right here. Nitrate, you're not going to find this. This is not nitrogen. This is a polyatomic ion, so similar to this one, that means it comes in its own separate package of that ion. It doesn't get broken up. So this is going to be an ionic bond because this one has a polyatomic ion. Likewise for letter F, this is potassium, the same potassium in number 19. And sulfate, again, it's not sulfur, but sulfate is its polyatomic ion or complex ion. So this is going to be ionic as well. And the last one, calcium chloride. Calcium's here and chlorine's here. Chlorine, chloride, so this is going to be your ionic bond. So that's how you identify ionic or covalent bonds. So if we were to look at number 6, this is naming ionic compounds. Naming ionic compounds is different than than covalent because ionic compounds do not need the prefixes. So how you name this is just the first element stays the same. The second element, regardless of how many you have, you just need to change the ending with the IDE. So the first one here is MgBr2. You notice that Mg is right here and Br is right there. That means it's an ionic bond, and this is just going to be your magnesium. My pen doesn't really work here. Bromide. So this is your magnesium bromide. I just got right really slow. And then the next one is KCl. Potassium is over here, and Cl is over here. So this is going to be, again, this is your potassium. This is potassium chloride. So notice that all the endings contain the IDE ending, just like your bromide. And then the next one is your aluminum sulfide. So then you have your aluminum here, and then your sulfur is here. So this is going to be your aluminum. So this is aluminum sulfide. So that's your aluminum sulfide. And then the next one is magnesium phosphide. So you see that magnesium's here, phosphide is over here. So you notice that, again, this is a metal, non-metal, so that's an ionic bond, so you don't need prefixes. So we're going to look at what prefixes mean in the next question when we go into your covalent compounds. So this one is going to be magnesium phosphide. Oh man, my pen is just not working that well. Phosphide. PHIDE. So then let me erase this board and I'll be right back. So for the next part, this is naming covalent compounds. So for covalent compounds, again, this is your non-metal and a non-metal. And in this case, you actually need prefixes. So in your prefixes, this is what you have to put before your element to indicate how many that you have. So the prefixes, one is for mono. So if you have one element, one atom, I should say, is mono. 2 is di. 3 is tri. 4 is tetra. 5 is penta, and then 6 is hexa. And I don't think we're going to see that many beyond 6. And let's answer these questions. So if you look at this one, this is P4S5. You notice that phosphorus is here and sulfur is right here in the non-metal side. That means it's a covalent bond. And because I have 4 phosphoruses, I need the prefix tetra to indicate that. So this is tetra phosphorus. And then because the next one, I have 5 sulfurs, so I need penta, P-E-N-T-A. And then this one actually contains the ending similar to your ionic IDE, sulfide. The next one is nitrogen dioxide. So this is your nitrogen. The first one has 1, but you don't really need the mono for nitrogen. You only usually use the mono for oxygen. So for nitrogen, you can just say nitrogen, but for oxygen, because you have 2 of them, you're going to use dioxide. So that's going to be your NO2. And to look at SeF6, I'm going to just write it here. Se is your selenium, so this is your selenium, and because you have 6 of them, this is going to have the prefix hexa. And then the last part is just going to be your fluorine, but it would have your IDE ending. That's what I'm trying to say here. And then the last one is Si2Br6, and because you have 2 silicones, so it's going to be disilicone. So disilicone. And then you have 6 bromides. This is going to be hexa bromide. That's how you name these ones. So again, covalent bonds, you will need prefixes. Ionic bonds, you don't need prefixes. So then we did number 7 already. Number 8, we're going to look into the type of reaction. And there are basically 5 reactions that we have to know. And if you look at the first one, this is a single displacement, because whenever you look at a reaction, you look at how many elements that you have in the compound. So magnesium, it's just a standalone element. This is 1. But if you look at HCl, you have H and Cl together. That means you have a positive and a negative. So why is this a single displacement? The reason is that the positive of magnesium is going to switch places with the positive of the hydrogen. So where did I get this positive from? If you look at magnesium, this is an alkaline earth metal, and because it's on the metal side, this one has a +2 charge. And if you look back over here on this one, let me just kind of pull this up. This one will have a +1 charge for hydrogen. So here, because it's in group number 1, alkali metal, this one will have a +1. So in a single displacement reaction, this positive side will change places with the other positive side. So then the Mg will combine with Cl2 and then giving you H2. Why H2? This is part of the group called the Hofbrinkel group, which means that if they're by themselves, you would need to have them bonded to itself. That means that H will be H2, O will be O2, F will be F2, Br will be Br2, I2, N2, and Cl2. So that's your first one. For B, this one, your products are water and carbon dioxide. Anytime you get water and CO2, that's like a big kaboom kind of reaction. This is your combustion. So for letter B, this is your combustion reaction, because anytime you're burning anything, you're giving off CO2 and also water as well. For letter C, you have, again, I'm going to identify that this one has 2 and then 1. So then because I have 2 and 1, I have a single displacement. So what elements would get switched? The ones with the same charges. So copper is a transition metal in the middle. So that means it's a metal, it will have a positive charge. Whereas your hydrogen, this one is going to swap places with copper, making water. So H2 and O with copper by itself. So you're just making your copper metal by itself. And then for D, you can see, let me just kind of erase this and get this out of the way. For D, you can see that I have two separate things to make one big thing. So that means that I have a synthesis reaction. So for letter D is your synthesis reaction. And then for letter E, I have let me just kind of erase the beginning stuff. For letter E, I have 1 here, and then this compound has sodium and oxygen. So I have 1 and 2. That means it's going to be a single displacement. I'm just going to say SD. And then for letter F, I have HCl and then CaOH2. This is a double displacement reaction, also an acid and base reaction. So why is it a double displacement? Because if you look at HCl, you have a plus. You have a hydrogen and a chlorine, and then your CaOH2 has a Ca and OH combined to each other. That means you have 2 and 2, making it double displacement. And why is this one an acid and base? Well, HCl is actually hydrochloric acid. CaOH2 is calcium hydroxide, because you have an acid combining with a hydroxide. That is a neutralization reaction, or acid and base, giving you water and a salt as your products. And then finally for letter G, you have CaCO3, one thing, one big compound, and then this yields into 1 and 1. You have 2 separate compounds after that. That means that this must be a decomposition. That means it's going to break one big compound into 2 or more smaller bits from that. So that's a decomposition. And then last one, letter H, this is your H2 plus O2 combining into one big thing. So you have 2 separate things making into one big thing. This is, again, your synthesis reaction. So this is your first page of your exam review. Hopefully you guys did a great job, and I'll see you in a little bit for the next part. So let's look at the next question. This is going to number 9, which is just looking at balancing. So whenever we're talking about balancing, this is actually tying in with the law of conservation of mass. And what that means is that in a chemical reaction, the reactants reacting should retain its mass after its reaction. So then that means that the mass, the number of atoms in its reactants, and after the reaction has undergone the reaction, the product should have exactly the same number of atoms or the mass as well in a closed system. That means no other external influences. So that means that this actually comes back to balancing equations. So if we were to look at number 1, or letter A, we have to look at the reactant side, and the number of atoms on the reactant side, are they the same as the number of atoms on the product side? So if you look at this one, magnesium has 1 here, and the magnesium has 1 here. So that's good. The rule of balancing is that you cannot change the number, the subscript. You can't make this MgCl2 into like Mg5Cl7 or Mg2Cl2. What you can change is the number of MgCl2s you have, and that's by putting a number in front of it, like 2 times MgCl2, or 5 in front of it, 5 times MgCl2. That means that you have 5 of them. So if you look at this one has HCl. That means that there's 1 hydrogen, 1 chlorine. However, on the right side, there's 2 chlorines and 2 hydrogens. So in order to balance that, I can just put a 2 in front of it, because by putting a 2 in front of it, I would have 2 hydrogens, that's check, and 2 chlorines, and that's check. So that's balanced. It's always good to go back and balance it. Letter B is a combustion reaction. Combustion reactions are usually pretty tricky because the numbers are actually going to be very big. So if I look at this one, I can see that there's 4 carbons here and 1 carbon here. My first intuition is, let's make this a 4 to balance the carbon. So let's try that out. And then by putting a 4, remember, this influences my number of oxygen. So 4 times O2 means I have 8 oxygens on one side, plus this lonely oxygen here, which will give me 9 oxygens. But the thing is, odd numbers are really difficult to balance. So what I want to do is actually make this into an even number. So then let's make this into this odd number to even number. Let's multiply this by 10. Let's just to try it out. So by putting this number 10 in front of H2O, that actually changes my number of oxygens. So I have 10 oxygens, and then I have 8 oxygens on the other one, giving me a total of 18 oxygens on the right hand side. So if I were to have 18 oxygens, okay, that's easy because this is O2. I just have to put a 9 here. But we're not done. If you were to look at this, my carbons and my hydrogens are actually not equal, because if you look at my hydrogens, I have 10 here, well, I have 20 here. So that actually offsets that a lot. So what if I were to put a 2 here? So in balancing reactions, you actually have to trial and error and try it out. And sometimes it does get pretty frustrating because you play with one number, then you have to double check and it doesn't work. But the good rule is that try to make those elements that are odd into even numbers by multiplying by a coefficient to make them an even number. So then here, I have 8 carbons here. I have 4 carbons. Let's change this to 8 carbons. Let's see what happens if I put an 8 here. So that means I have 8 carbons on one side, so that's 8C. So let's just split this. And then I have 8 carbons because I changed that into 8, so that's 8 carbons. How many hydrogens do I have on the left side? 20. So I have 20 hydrogens. And then on the right side, I have 20 hydrogens, so things are looking promising. And then finally, my oxygens, I have 18 oxygens. And then now I have 10 plus 8, which is 18 oxygen. So now I'm balanced. So this is 2, 9, 10, and 8. That gives me your, oh wait, hold on a second. This is 18, 10, and then I need to have a 4 here, which is 8. Yeah, that's it. That's your balancing reaction. So let me erase all this stuff. And then let's look at letter C. So letter C, you have CuO plus H2 plus Cu H2O. This one looks like it's already balanced. I have 1 copper, 1 oxygen, 1 oxygen, 2 hydrogens. So this one's balanced already. Oh, that's good. And then for letter D, I have 2 nitrogens. So let's put a 2 in front of this. By putting 2 influences my H3. So that means I have 6 hydrogens on this side, but only 2. So I'm going to multiply this H2 by 3 times, giving me 6 hydrogens. For letter E, this is H2 plus Na2O. So then let's look at my sodiums. I have 2 on the reactant side, just 1 on the product side. So put a 2 here. My hydrogens look balanced. That's good. My oxygens look balanced. So does my sodium. So that's balanced as well. For letter F, this is a double displacement or neutralization reaction. I have an acid and a base. So then HCl. So then how many chlorines do I have? I have 1 here, 2 here. Let's put a 2 in front of this. By putting 2 in front of that, I have 2 hydrogens plus this OH with a bracket 2. That means I have actually 2 OHs. That means I have 2 hydrogens and 2 oxygens here, giving me a total of 4 hydrogens on the left side. I have just 2 here, so let's put a 2 in front of this. And because I put a 2 in front of this, I have 2 oxygens as well, which is great because it actually balances out my 2 oxygens on my reactant side. So this is now balanced. Letter G, I have Ca here, 1 to 1, that's good. I have 1 carbon, that's good. I have 3 oxygens. That looks kind of complicated because it's odd, but luckily I have 1 oxygen plus 2 oxygens, giving me 3 oxygens. So this was already balanced. And finally, my last one, this is your hydrogen gas with your oxygen gas making H2O. So if I just put a 2 in front of the H2O and then 2 in front of the H2, will give me a balanced reaction. So that's your first part of your exam review, and hopefully that has helped you look at the periodic table, the groups, bonding, naming especially, and also balancing and identifying the types of reactions. So hopefully this video has helped you. So see you next time.